Architecture of 8086, or what is the internal structure, or how does 8086 look like what are the registers, how are they arranged, we will see in this video. So mainly 8086 is divided into two parts. First is the BIU or bus interface unit, and second one will be our EU or execution unit. In bus interface unit we have the interface or the memory address that will have the address lines through which the data and address can go. So we have 16 bits of data and 20 bits of address. So this is our memory address and data bus interface. Then we have our internal data bus. The internal data bus, these are connected. Then we have the address converter and the registers. What are the registers present here? Segment registers and the IP register. Segment registers are code segment, data segment, extra segment and stack segment. Next, these all are connected. Then we have here instruction byte queue. What is the work of instruction byte queue? We will see. Then in the execution unit we have the same internal data bus, from which we have our ALU or arithmetic logical unit, to which flag is connected, and these all are connected with the internal data bus, because from the internal data bus we will take the data and execute in the ALU, and then accordingly our flags will be updated. Here we also have our registers, the GPRs, then pointers, and then indices or the index registers. Index registers are SI and DI, source and destination. We have total 3 pointer registers and one of them is here, so we have now only 2 pointer registers, stack pointer and base pointer. Then the 4 GPRs, AX, BX, CX and DX. And from the instruction byte queue we have the decoding unit, which will decode the instructions, and also the timing and control diagram. So this is a rough diagram. We can get this diagram from anywhere in the internet. And here the bus interface unit, this part is only for interfacing with the outside lines like the address and the data, which contains interface, this interface, and then address converter. What is the work of this? Whatever we have, we used to, if we have CS, we will do CS into 10 plus IP to get the current instruction. This task is done in the address converter. Here the value of CS is shifted by 4 bits. Suppose we have shifted left, suppose we have 5000H, then it will be shifted left by 4 bits, which means it becomes this much, and then we will add the IP address. Suppose IP is 5000 again, so we will get our net effective physical address. We will get from here, and then accordingly through the internal data bus we will fetch whatever data we need from that address. That is the work of the address converter. We have here segment registers, so that we can shift it left and then get the addresses.